Welcome everyone to today's class. This is a very important topic and we are going to cover divisibility rules, one of the most important topic, and if you master this, you can attempt many questions in factorization, divisibility, and many other number problem arithmetic operation you can solve just in a jiffy. Just to let's start with, we are going to generalize the divisibility rules of prime numbers and the divisibility rule which you have learned in the class. I am going to show you a very innovative way. So stay connected, stay tuned. Let's start with. So what is divisibility? Divisibility means that after dividing, there will be no remainder. Divisibility rules or divisibility tests make the division procedure easier and quicker. Or to be very frank, you can tell the number whether it is divisible or not just by looking at the number without actually dividing it. So let's see. So first we are starting with some interesting rules. So if there is a number which is a triplet, so what do you call a triplet? So triplet is a number like 1, 1, 1. Three numbers are repeated are called triplets, like 2, 2, 2, like 3, 3, 3. Any numbers which are repeated 3 times are called triplets. So if you have a triplets, then it must be divisible by 3 and 37. So a number which is a triplet will be always divisible by 3 and 37. So you don't have to divide with, and just you learn this rule, understand this, and then you can apply this in exam. Most common question in most of the Olympiad. Now, if a number is repeated 6 times, so I mean you write a number, any number 6 times. Okay, like this, then it will be divisible by all these number 3, 7, 11, 13 and 37. I mean any numbers which is repeated 3 times will be divisible by 3 and 37, and if it is repeated 6 times, then will be also divisible by 7, 11 and 13. So this is another yet interesting fact. Let's go to the next slide. So here let's start with a very divisibility rule for 25. Have you heard of this? So divisibility rule of 25 and divisibility rule of 4 are same. How it is same? For divisibility rule of 4, always you are checking the last 2 digit. If the last 2 digit is divisible by 4, then that number is divisible by 4. So same rule start here, it works here. A number is divisible by 25 if it ends with 0, 0, 25, 50 or 75. That means my last 2 digits must be divisible by 25. Okay, so if you see 25 table, it alternate, no, 25, 50, 75, 100, and then it's repeat 125. So that's how I have generalized. If it is 0, 0, 25, 50 or 75, it will be always divisible by 25. So what do you have to do? The rule say if the last 2 numbers of a very big number, any big number you write, and that's end with 0, 0, 25, 50 or 75, it must be divisible by 25. Okay, let's see divisibility rule for 4. So same rule apply for 4 as well. So you have to check only the last digit. If the last 2 digit is divisible by 4, the number is divisible by 4. So only thing what you have to take care is you have to put last 2 number, if it is having 0 at the end, will be divisible by 4. Now let's see the next one. So divisibility rule for 125. So when we are having 125, so suppose you have a very big number like 27859,420, and then in the last you have 125. So if the last 3 digits of a number are divisible by 125, so only we have to check for the last 3 digits. If the last 3 digits is divisible by 125, the number will be divisible by 125. The same as the 8 rule. So divisibility rule for 8 is the same. If the last 3 digits of the number are divisible by 8, then the number is completely divisible by 8. Now, divisibility rules for 7, 11, and 13. You are going to club this and you are going to study together. If you remember one rule, you can check the divisibility rule for all the three prime numbers, 7, 11, and 13. Let's start with a smaller example. So 2093. So what you are going to do, so you are going to make a group of 3 starting from this side. So what do you come? 93, because 0, 93. So you subtract 93 minus 2, 91. So is 91 divisible by 13? Yes, 13 times 7 is 91. Is 91 divisible by 11? No. So this is divisible by 13, divisible by 7, but not divisible by 11. Okay, so let's try another number. Suppose you have 4095 and we check the divisibility for 4095. So again, you group into like this. So 095 minus 4 give you 91, and this 91 again is divisible by 13 and 7, but not by 11. So you check the divisibility rule for these three primes by one single rule. Now suppose you have 16042. So when you group into three digits one time, so 42 minus 16. So how much you got? 26. So is 26 divisible by 13? Yes. Is 26 divisible by 11 and 7? No. So this can be only divisible by 13, not by 7, not by 11. Okay. Let's try another number. 54864. So group into two parts like this. So what do you have to do? 864 minus 54. How much you got? 810. So is 810 divisible by 7? No. Is 810 divisible by 13? No, because 910 is there. Is 810 divisible by 11? No. So this number is not divisible by either of the numbers. Now let's try this big number. So when we have this number, then this will be plus, this will be plus, and this will be minus, because alternate plus and alternate minus. So first you add 989 plus 11. Okay. 9 plus 1, 10, 8 plus 1, 9, 10, and 10. So 1000 minus 37. So 963. So 963, is it divisible by 13? You can check. 13 times 7, 91. So 53. 53 is not divisible. So not by 13. Check by 7. 7, 1 just 7. You can do one more time. We'll check the divisibility rule of 7 also separately. And that just the method works very well. And just you have to group into threes, and then you have to alternate plus and alternate minus. Here also you can try this way and put the answer in the comment box. So 2 minus and 2 plus. So try it and do it in the comment box. Waiting for the answers. Now let's try with the numbers which we are learning from the very beginning of your academics. The divisibility rule of 2 says, if the unit digit of the number, I means this unit digit of the number is even number, that means it has 0, 2, 4, 6, and 8, the number will be divisible by 2, right? We have been learning this rule since the beginning. Now, divisibility rule of 3 says, what we have learning in the school, we are going to add this number and form the sum rule. So it actually take time. You have to find the sum and you have to check the divisibility. So what you do here, so instead of doing the sum rule, what I suggest is easier that you cut all the multiples of 3. Like 3, 6, 3. All get cancelled. We got 0. Is 0 divisible by 3? Yes. So the number will be divisible by 3. Let's try another set. 2, 1, 4, 7, 2, 3, 2, 5. Suppose we have a number. Now we are trying to make 3 or 9s. 3 cancel. 7 to 9 cancel. 4, 6 cancel. 2 plus 1, 3 cancel. What I left is only 5. Is 5 divisible by 3? No. Let's take another example. 5, 4, 8, 3. 3 get cancel. 8 plus 4, 12. Cancel. 5. 5 is not divisible. Let's take another example. 3, 5, 7, 2, 5, 4. 5 plus 4, 9. Cancel. 7, 2, 9. Cancel. 5 plus 3, 8. It is divisible by 3? No. So the number is not divisible by 3. This is much, much easier and faster than doing the sum rule. So I always suggest go by this method instead of doing the traditional sum rule method. You have to be smart to crack the exam and to be ahead from the other competitors. So divisibility rule for 5 says the unit digit of the number must be 0 or 5. So much, much easier, like 4, 5, 6, 0. So this number will be divisible, like 3, 5, 3, 5 will be divisible. Very, very easy rule. Nothing to be worried for here. Divisibility rule of 6 says we will test the number for 2 and we'll test the number for 3. For any composite number, that is the same rule, that you have to break into prime factors and then you have to see the divisibility. So divisibility rule for 6 says we will check whether the number is even and then we'll use the sum rule to check if it is divisible by 3. So if it is divisible by both 2 and 3, then only it will be divisible by 6. Let's take divisibility rule for 7. That is not taught in the school, but this is a very, very handy method and it can work wonders for you. Let's try a number like 826. So this number you multiply it by 2 or double this number. How much you got? 12. Now you do 82 minus 12. How much you got? 70. Is 70 divisible by 7? Yes. So the number is divisible by 7. Let's try any other number and then you can master this. So suppose you have 41720. So 0 will skip because any number, if you put 0, it doesn't make a difference. So we'll start with 2. So double 2, that is 4. So we are going to subtract 4 from the truncated number. So how much you got? 413. Still you cannot do? Okay, no problem. So 3 you double. So 6, subtract 35. Is 35 divisible by 7? Yes. So the number 41720 is divisible by 7. Very, very important rule and very, very handy rule. Just please note it down. Divisibility rule of 9 is same as divisibility rule of 3. Only thing you are going to cancel here 9 pairs. So 9 finish, 6 and 3 finish. Now 4 and 5 finish because they add up to 9. What is left with? 3 plus 2, 5. Is 5 divisible by 9? No. So the number is not divisible. Let's try any other number. Very big number. Okay. So you are searching 9. 5, 4, 9. Cancel. 6, 3, 9. Cancel. 7, 2, 9. Cancel. 5 and 4, 9. Cancel. 6 and 3, 9 cancel. What I'm left with? 5. Is 5 divisible by 9? No. So the number is not divisible by 9. This is much, much easier than the sum rule. You don't have to go for the sum. Divisibility rule of 10, again, very easy. So just the unit digit must be 0. So only you have to search for the unit digit, that must be 0. Now, divisibility rule of 11, there are 2 rules. I'll demonstrate both of them to you because one rule you have been studying since your class, like the alternate sum, alternate, like suppose you have a very big number 5, 8, 3, 6, 9, 8, 8, 7, 6, 2. So you take the alternate number 2, 7, 8, 6, 8. Okay. So instead of adding the sum, what I suggest, the numbers which are not rounded, you can cancel it off. So 8, 8 finish. Now again, here you have a 6, here you have a 6, cancel it off. Now, you see 5 plus 3, 8 and 8 cancel off. So how much is left? 9 here and 7 to 9. So that add up to 0. because you assume, or you can write this way because you understand. Otherwise, I can also tell you this way: 6988762. This number you assume that these are minus. Let me write a fresh. So suppose 58369888762. One method is that you are going to add the numbers in the odd places like 86872, and then you are going to add 53986. Why don't you cancel it? Because we assume that this is minus, this is plus, this is minus, minus, all the numbers in the bracket are minus. So plus, minus, cancel off, plus, minus, cancel off. And similarly, you can see which numbers are cancelling. 729 cancel off, right? So this way, if you cancel off, your job is very, very easy. 6 and 6 cancel off. So you can see all of them add up to 0. So the difference is 0. So the number will be divisible by 11. Here I'm going to teach you another important rule for seeing for 11. So we have teach you two rule. First, I started with one rule, that is truncation method into groups of 3. Then alternate sum of odd and even. And this is another method. So just take a note of this: 19151. So the last number you take 1 and then you multiply it by 4. Subtract the last digit from the remaining limiting truncated number. So if the result is divisible by 11, then so was the first number. So what do we have to do? 1915, and then we are subtracting 1 from this. So what you get? 1914. Now again, 1914. Now again you check the last digit, 4. So you subtract 187. Okay, you can check here only 7 plus 1, 8. So this is 17 times 11, right? So you can check 187 is divisible, right? So this is very important rule. So any number you can check the divisibility by 11 by this method. What we have to do, very, very simple method. So what you have to do, just you have to multiply the number, last number by 1, or multiplying by number is same like not multiplying. So what do you have to do? So you take any number, right? We take any number, suppose 8 to 8. So this number we subtract. So how much you got? 74. Is 74 divisible by 11? No. So like that you can do. Suppose you have 3, 3, 3, 3, 3, 3. This way it is be easier. Let's do any number. Like suppose 1, 5, 2, 3. So last digit you subtract from this. So how much you got? 149. Is 149 divisible? Just check. Subtract from 9 here. So no, 5 is not divisible by 3. So this is another very, very important method. So divisibility rule for 12, I say whenever you have composite number, what we need to do, you break into its prime factor. So here we have 4 and 3. So 4 and 3, so we have to check whether the number is divisible by 4 and 3, right? If it is divisible by 4 and 3, the number will be divisible by 12. Divisibility rule of 13, yet another prime number which is coming every time in the exams. And here the rule is very simple. So suppose you have any number 50661. So take the last digit, multiply it by 4. Okay. So 1 times 4 comes 4. Okay. So add 4 times the last digit to the remaining leading truncated number. So remaining number is what now? 5066. So you add here. So how much you got? 5070. Now 0. 0 if you add it will not make difference. So let's take, because 0 multiplied by any number will be 0 only. So let's take 7. Okay. So 7 into 4, 28. So 50 plus 28 give you 78. Is 78 divisible by 3? Yes. 78 divided by 13 gives you 6. So this big number 50661 is divisible by 3. You can also truncate into this part, 661 minus 50. And you can check the divisibility rule by this, but this is very, very simpler. Both the methods are easier. It depends on what you want to use and what you remember in the exam. Now, divisibility rule of 14, 15, 16, and 18 are another very, very easy. Here you have to check 2 and 7. Here you have to check 3 and 5. Here, if the number last 4 digit, you have to check last 4 digit, because till 8 you are checking 3 digits. For 16 you have to check 4 digits, and here you have to check for 2 and 9. Okay, so that way you can check for these composite numbers. Now let's do for divisibility rule of 17. So 17 is subtract. Suppose you have a number, so always we take out the last number, and then we multiply by 5. How much you got? 40. So now 397 minus 40. How much you got? 355. Again, you take the last digit. 5 times 5, 25. Okay. So subtract. So here what we do? So first number we take 8, and then 8 we multiplied by 5, 40. Remaining number we subtract. So 7 minus 0, 7, 5, 3, 357. Okay. Now 7 you multiplied by 5, 35. So how much you got? 0. Since we got 0, so the number is divisible by 17. Let's try another number, divisibility rule for 19. So for 19, what we need to do, first you take the number. Okay. So now we take the last digit, that is 6, and then we multiply it by 2. So how much it comes? 12. Add them to it. Now again you take the last digit, 7, 14. Add. Again you take the last digit and double it. So 114. Is 114 divisible by 19? Yes, by 6 times. So this number is divisible by 19. So similarly, we can try for 12483. Take the last number, double it, and add it. So you got 1254. Again, double it and add it, 133. Again, double it and add it, 19. So 19 is divisible by 19. So that's how you can check for 19 as well. So now, instead of remembering what is the rule for each prime number, what you can do, thus you can derive yourself. So what you have to do, find a multiple of p closest to any multiple of 10. Suppose I go 13, so 13, 26, 39, and then 13 to the 20, 13 to the 52. So closest to 13, what I got? 39, which is closest to any multiple of 10. If I put 10 into 4 minus 1, that's how our oscillator is 4. This K is called the oscillator. So you can derive your own oscillator for any prime numbers, and then that is very, very easy. For without learning any formula, you can just derive your own oscillator and you can define your own divisibility rule. Thank you. Take care. Bye bye. What did this thank you? I love